Our next speaker is Dr. Kim. What is the program you're on after this? No problem. Our next speaker is Dr. Kim.
Hello, I'm Yohan Kim from Japan, Gifu University. Because I'm not a native speaker and not good in English, so I will speak slowly. And in this presentation, I'd like to talk about the relationship between the ruminal pH and bacterial community during weaning transition. In this study, we paid attention to the weaning transition period. Weaning transition is defined as the period of transition from liquid to solid feed consumption. This period is critical for the development of an active and functional rumen. In dairy industry, feeding highly fermentable carbohydrate have performed to increase the energy production, such as VFA and lactate, and so on. This management could enhance the absorption of the ruminal VFA as well as the ruminal epithelial growth. However, excessive amount of carbohydrate feeding imposes a challenge to maintaining the homeostasis of the rumen. If the diet changes, ruminal bacteria should adapt to this alteration of substrate. Previously, several studies were reported. Among them, a study reported that forage feeding alleviates the depression of ruminal pH. Then, several studies also revealed that rumen bacterial microbiota differed between dairy cattle fed a high grain diet versus a high forage diet. Also, depression of ruminal pH affects the ruminal bacterial diversity and composition. However, the relationship between the ruminal pH and bacterial community during weaning transition have not been well studied. Therefore, the objective of this study is to investigate the relationship between the ruminal pH and bacterial community in calves fed calf starter with and without a forage diet during weaning transition. Sixteen 4 weeks of age Holstein bull calves were obtained from dairy farms. Calves were raised by milk replacer, calf starter, and mixed hay. For the experiment, all calves were subjected to 3 weeks of adaptation and equipped with rumen cannulas 4 days after arrival. Feeding management was followed by Japanese Society of Animal Science. During the adaptation period, calves were raised by same management between the two groups. At 6 weeks of age, calves were assigned to the forage supplemented hay group and forage non-supplemented corn group. At 7 weeks of age, weaning was started in both groups by reducing milk replacer by half, and forage was restricted in the corn group. Then all calves were weaned at 8 weeks of age. Ruminal pH was measured every 10 minutes throughout the experiment. For the analysis of VFA and bacterial community, rumen fluid samples were collected at 7, 8, 9, and 11 weeks of age, namely -1, 0, 1, and 3 weeks of age, weeks after weaning. The V1 and V2 regions of the 16S ribosomal RNA gene was amplified using the microdid primers, and all virus sequencing reads were filtered by analysis pipeline by Kim. Filter-fast sequences were processed using mother software for the bacterial diversity analysis. Quantitative real-time PCR was performed to evaluate this bacterial copy number. This line graph represents daily changes in the 24-hour mean ruminal pH. Vertical and horizontal line represent ruminal pH and days after weaning. The solid and dotted line represent the -1 and 0 weeks after weaning, respectively. This blue line represents the hay group, and red line represents corn group. The 24-hour mean ruminal pH was significantly higher in the hay group, and differences in the ruminal pH were signified by the increase in the hay group and decrease in the corn group after weaning. This line graph represents diurnal changes in the 1-hour mean ruminal pH. Horizontal line represents time of day, and these arrows represent feeding time over day. 1-hour mean ruminal pH also significantly higher in the hay group, and diurnal changes in the ruminal pH were identified in the hay group throughout the study. However, they were not observed at 0 and 1 week after weaning in the corn group. This line graph represents total VFA concentration and individual VFA VFA and AP ratios. Vertical line represents VFA concentration and proportions of individual VFA and AP ratio. The proportions of acetate and propionate were significantly higher and lower in the hay group. Ruminal AP ratios were significantly higher in the hay group, and these results were generally consistent with previous studies that related to high-grain diet feeding. This line graph represents ruminal bacterial diversity. In the diversity analysis, diversity indices decreased after -1 week after weaning. And however, ACE, COW1, and OTU indices rebounded at 0 week in the hay group and 1 week in the corn group after weaning. Furthermore, the observed OTU was significantly higher in the hay group at 1 week after weaning. This bar graph represents relative abundances of 4 major phylum and their genus. Vertical line represents relative abundance of phylum and genus, and horizontal line represents -1, 0, 1, and 3 weeks after weaning of the hay and corn group. Of the viral sequencing data, Firmicutes and Prevotella was the most abundant bacterial phylum and genus in both groups. The significant differences were observed in Bacteroidetes phylum and Actinobacteria phylum and Prevotella genus. Actinobacteria was mostly occupied by this Ursinella genus that can ferment carbohydrate to lactate, and this genus was the most abundant lactate-producing genus in the corn group. Lactobacillus, which belongs to Firmicutes, is the most abundant lactate-producing genus in the hay group, like Ursinella genus in the corn group. This Proteobacteria was mostly occupied by Haemophilus and Succinobibrio. These line graphs represent the copy number of bacteria by real-time PCR. Vertical line represents log transformed copy number of bacteria, and horizontal line represents weeks after weaning. Ruminal albus and Ruminal flavifaciens were significantly higher in the hay group at 3 weeks and 1 week after weaning. The higher copy number of Streptococcus bovis was identified in the hay group after weaning. Feeding forage mitigated the depression of 24-hour mean ruminal pH in the hay group. This mitigation was mainly caused by a rebound from a rapid decrease in ruminal pH after feeding. From the viral sequencing analysis, Prevotella genus, the most abundant genus in both groups, could constitute a crucial member of the ruminal bacteria in dairy calf during weaning transition. Also, bacterial diversity indices were greater and recovered more rapidly from the damage by weaning transition in the hay group. From the real-time PCR, cellulolytic bacteria such as Ruminal albus and Flavivaciens were significantly higher in the hay group due to the feeding of forage diet. In conclusion, changes in ruminal pH affect the ruminal bacterial composition and diversity, and these changes might have influenced the establishment of fermentative ruminal functions during weaning transition. Thank you.
We have time for one brief question on Dr. Kim's presentation. I have a very simple question. What were the calves bedded on?
Bedded on, all calves were bedded in rubber mat.
Rubber mats?
Yes.
No straw, no hay?
Yeah.
Just rubber mats?
Yeah.
Excellent. Question down here.
Hi there, Tom Lyons from Lanes Vets in Holstein. Just a quick question, was the consequence of these differences followed up at all in terms of calf health or growth rates?
So did you monitor in the study the health of the calves and how quickly they grow?
Yes, but there was no difference between the two groups in the calf performance. Yes.
No difference in calf performance between the two groups?
Thank you.
Okay. Thank you again, Dr. Kim. Thank you.